Hello everyone and come on in. Welcome to our webinar for tonight, getting started with blockchain programming. Hope everyone can hear me well and see the screen. Tonight we're sharing the slides for our free webinar all about our blockchain programming class. It begins in just 2 days, so you still have a couple days left to sign up for those last few spots. I'm also going to drop a link to the slides in the chat. So if you want to save the slides or read them later, then just go to that link that I dropped. So welcome everybody. Here's our agenda for tonight. First, we're going to introduce Lumiwealth and what we do here. And then we're going to cover 4 main topics, introducing blockchain and some of the terms that you need to know in this space. And the goal is to give you a teaser of what is to come in our blockchain programming course. It runs for 8 weeks and we begin it on Thursday, and there will be a holiday break, but otherwise it's 8 weeks long. Now in this course, we're covering theory, giving you a general overview of these topics. And then in the actual course, we do a lot more hands-on projects. So tonight, we're not going to be building any large projects, but in the course we do build different projects. Tonight we'll cover why learn the blockchain, what are some blockchains like Bitcoin and Ethereum, what are smart contracts, and 2 popular topics, cryptocurrencies and NFTs. How do those work? So these will be our 4 large topics for the night. If you have any questions throughout the night, please feel free to ask. We will also have time at the end for any extra questions. Let's begin by getting to know some of you in the chat. If you feel brave, please let me know in the chat, what is your occupation? Do you know how to code? And how much blockchain experience do you have? Have you invested in a blockchain, maybe cryptocurrency or another token or project? Have you ever coded before? This will help me understand the level of experience that you have. Usually my students are complete beginners, which is totally fine. You can still watch the webinar and follow along with the course if you're a complete beginner. In fact, usually my students are beginners. But if you let me know, this will help to make sure I can tailor the webinar for you and also tailor the course for your level of expertise as well. So I will begin. My name is Alexandra. I'm an instructor here at Lumiwealth and also a software developer at Mammoth Interactive. And my journey began in 2017 when I invested in Ethereum. And since then, I've been teaching thousands of students online how to build blockchain projects like smart contracts, decentralized apps, just like you. So I hope that some of you will enjoy the content of tonight's webinar and that I'll see you in one of our courses at Lumiwealth. At Lumiwealth, we have many courses, primarily in the financial space, but now we're expanding to have more blockchain courses too, because of how much the blockchain is affecting the financial industry. You can check out our other courses at lumiwealth.com. We have many other courses coming this winter as well. We have one message from Patrick, a CTO at Index, 8 years coding experience, minimal blockchain development experience, but fascinated by the tech implications. Great, thanks for commenting. So yes, if you have coding experience, that will definitely help you get a leg up building the projects in the course and just building blockchain projects in general. We also have a YouTube channel, youtube.com, search for Lumiwealth. And we're going to be posting this webinar on YouTube and on Circle. So if you want to watch back, then that's where you can go. Please subscribe to us on YouTube. We do post free webinars, and we also post interviews and tutorials, reviews from students. So check out our YouTube channel. We have another comment from Austin. I work in marketing and have experience in web development. I'm trying to get into blockchain development. Okay, great. If you have experience with web development, that means you have some experience coding. So that will also help you enter this blockchain coding space. You might also be interested in our Web3 course that we also have here, which is all about using the blockchain in web development. Okay, we're also on Circle. Of course, if you're watching live, you already know. But otherwise, everyone else, join us at lumiwealth.circle.so. And we have a Discord channel, although Circle is primary, Discord is more secondary, but you can still find us on Discord if you want to join. You don't have to be a student. Anyone can join the Discord and Circle and ask questions and participate. All right. Without further ado, we can jump into our first topic of the night. Why learn the blockchain in the first place? Why did we create this course about a year ago? Well, it's an exciting space to be in. Some of you have said you're fascinated by the technology and you want to get into this space. So likely you already have some idea of the interesting projects you can build with blockchain technology. It is a relatively new field compared to other fields and other type of software development. So this means there's a lot of opportunity for innovating and building projects. And the blockchain, this technology, can affect any industry which uses software, because the blockchain is just a piece of software and you can connect it to any other piece of software with code. So we see tons of different industries, from finance to web development to even music and games, all of these being affected by blockchain technology, where that software is being connected to decentralized software. And currently, the most popular form of decentralized technology is a blockchain. We also see, of course, cryptocurrencies like Bitcoin. That's a large way that the blockchain is impacting the world. You know, cryptocurrencies began in the doghouse where it wasn't really accepted as payment. And nowadays we see large corporations like Starbucks allowing you to make payments in cryptocurrencies. So we see this adoption of the technology over time. Another very popular way that blockchain is changing the world is through NFTs, and they've been getting a lot of popularity as well. We'll talk more about these later on tonight. Non-fungible tokens, where you can represent some asset or object or virtual asset and track it and store it on the blockchain. But beyond those two popular ways, cryptocurrencies and NFTs, we also see the use of blockchain in software like video games, allowing cryptocurrency payments in video games, connecting NFTs to video games, or just tracking video game actions on the blockchain. We also see Web3. We had a webinar about Web3 yesterday. That is another large way that blockchain is affecting the world and technology, where this is a new form of creating websites where you add a decentralized layer to your web applications. And of course, many other companies across different industries. So all of those ways are some examples of how the blockchain is affecting the world. And we see more and more of this decentralized technology being integrated in companies large and small. So it's a great time to be a blockchain programmer, because there are relatively few programmers compared to other types of programming. Blockchain is also called the future of the internet because of this Web3 side to the blockchain, where it's transforming how websites are made and therefore how the internet works and how websites that we go to daily function. Another reason to learn the blockchain is to make better investments, because in the course you'll learn how to read smart contracts, so how to read what is happening on the blockchain. So you'll be better informed about what you're investing in, because everything on the blockchain is transparent, so you can go and read exactly what the project is doing, what they're promising to do, and comparing it to what lives on the blockchain. So all of those are some reasons to learn blockchain. We've been running this course for about a year, and we'll run it again this winter in just 2 days. So it's a great opportunity to enroll because you can watch back on a whole year's worth of videos and then also start a new semester. So let's get into some of the technical detail now. Now we're hopefully excited to learn this technology. We see that its power goes beyond just the popular hype of cryptocurrencies and NFTs. There's a lot more you can do when you actually do programming on the technology. That's the goal of this course. So what are some blockchains and what is a blockchain anyway? So the technical term for a blockchain is a time-stamped series of immutable transactions. So time-stamped means that everything that happens on the blockchain, it gets recorded and it gets stamped with a date and a time, and all of the users or addresses, people that were involved in the action. This could be buying some coffee with Bitcoin, or this could be publishing or minting a new NFT, or deploying a smart contract, or it could be moving around in a video game if the video game is logging everything on the blockchain. And it is a series, which is another word for a list of items. So those of you that have experience with programming might help you to understand that a blockchain is like a linked list, where you have a list of items and they're all connected and you cannot break the chain. Blockchain is immutable, so you can not rearrange anything in terms of what events happened. You cannot go in and change any data about what events happened. You cannot edit your smart contracts, on most blockchains at least, where if I publish a contract, which we'll talk more about next, but if I publish something on the blockchain, I cannot go back and edit it. Everything is immutable. Same thing if I make a purchase with some cryptocurrency, I cannot just delete the purchase. Once you put it up there, it's permanently recorded. And this is a list of transactions. Now, this doesn't have to be buying something. This is just the term that we use for some kind of interaction that changes the state of the blockchain. So yes, this could be buying some coffee with Bitcoin, but it could also be any kind of interaction with a smart contract that's going to change some data. Like if I buy an NFT, or if I publish a smart contract, or if I want to change my username in a smart contract, all of those things are changing some data that's stored on the blockchain, or editing it or updating it. So that is considered a transaction. Why? Well, because you have to pay gas fees, which is a small fee every time you want to make some kind of change to a blockchain. And these changes, it doesn't mean that I'm going in and I'm erasing something and I'm then putting something new. No, because the blockchain keeps track of its history of everything that ever happened. As I already mentioned, everything's immutable. You cannot erase anything. You can make some updates that a smart contract allows, like if you're allowed to change your username in the contract. Let's say this is a video game again, and the video game is on the blockchain and you want to change your username. You can do that, but it will still have the record of what your username was before. And the developer cannot go in and they cannot edit the smart contract to remove usernames completely. You cannot actually edit the code that you already published. So that is the technical term for a blockchain, a time-stamped series of immutable transactions. And you can visualize it like a chain of blocks. And all these blocks are connected. You cannot break the chain because the blocks, they each contain data about some transactions that happened. And this chain keeps growing longer and longer. So every second or so, depending on the blockchain, every time someone interacts with it, if they do a transaction, the data about that, it gets put in a block, and then the block gets added to the end of the chain. So the blockchain is keeping track of everything that ever happened on it. Anytime you interact with a smart contract or you buy or sell something, all of that gets tracked. And that's just a visual, this chain of blocks, because actually a blockchain is made with code. So it's just another piece of software, but that is how we can visualize it with a metaphor. The number one property about a blockchain is its ability to establish trust. Now, of course, there's many other properties about a blockchain, but if you're going to remember just one thing tonight, then remember this. The number one property of a blockchain is to establish trust between parties without needing a third party. Instead, the third party becomes the blockchain. One example of this is making a large purchase like a house. Typically, if you want to make a purchase like that, you have to bring in some third parties to help establish trust and validity of the transaction. Maybe you bring in the bank, you bring in some lawyers, and you sign a contract to do verification as well that the owner of the house actually has the rightful ownership, and they're going to check you to make sure you actually have the funds to give them for the house. And so you bring in third parties to establish this valid transaction to make sure that you're not being scammed into buying a false house, or that the seller is not going to get scammed into selling their house to someone who doesn't actually have the money. So that is your traditional transaction. The blockchain allows you to do this kind of transaction with the same trust and same verification without having to bring in third parties, because instead the trust is established because the transaction is done through the blockchain. And you might be thinking, well, how does that give me trust? Just because I'm doing this over the blockchain, how is that any different? Well, the reason that doing a transaction over the blockchain establishes trust is that the transaction is done over a smart contract, which we'll talk about next. These contracts are like programs or applications, and they state exactly what will happen in the transaction. They'll say that the buyer will be checked to make sure the buyer has the money and that the money came from a valid source, that they're not trying to counterfeit it. The seller will be checked to make sure that the seller is the rightful owner of the house. And then the transaction will occur when the buyer sends the money to the seller, and the seller will send the ownership of the house to the buyer. And the blockchain does this all through a smart contract, which means that the buyer and the seller, they never actually interact. They never have to even talk. They just have to go through the smart contract. As soon as the buyer sends the money to the smart contract and the smart contract approves, the smart contract will then send the ownership to the buyer from the seller for the house. So each smart contract is different, but the developer of the contract will write it out in code and state exactly what will happen. And both parties, the buyer or the seller, they can go to the smart contract and they can see, they can verify the code. Will the code send the house for the appropriate amount of money? And the smart contract is autonomous. It runs on its own. All the buyer has to do is send the funds, and that will trigger the actions of the smart contract to run. So that's how the trust is established, because everything is independent of people. These smart contracts, yes, developers publish them to the blockchain, but after that, the developer cannot edit them because they're immutable. And they run without any oversight or any help. They just run on their own. So that's how a blockchain can establish trust. And you can also check at any time. If the buyer says, hey, I sent you the cryptocurrency for the house, but why didn't I get the house ownership? Well, the blockchain will track every action. So both parties can go and check, did the transaction go through? Did the buyer actually make the transaction? So everything is transparent. The code of the contracts is open for everyone to see. You cannot hide anything in the code of the contracts, nor can you hide any action that you did if the action is changing the state of the blockchain. Like if I want to buy your house, because I'm sending you the cryptocurrency and then the ownership of the house will change from you to me, that changes the data on the blockchain from ownership that's yours. Now the ownership will be mine. So that is going to get recorded. If you just want to check data on the blockchain, like you just want to see, who owns this house, who has the ownership, that does not get recorded. But if you want to actually change something, like buy the house, that will get recorded. So this also helps to establish trust because the buyer and seller can both see and check, did the transaction go through or is someone making a false claim? Now you might be thinking at this point, who is running this blockchain? These smart contracts, how are they running and where are they? Well, again, the blockchain is a piece of software. So that means it's written with code and it runs on computer processing power. So the way that it is managed is not actually in some central location because it's decentralized technology, which means that there's no central entity, there's no CEO, there's no location or warehouse where we have servers or databases to store the data. Instead, the blockchain is actually a peer-to-peer network. It's managed by a cluster of computers that use special computer algorithms to add new blocks to the chain every time users interact. So this peer-to-peer network is around the globe. And if you wanted to, you could actually take your computer and you could join the network. And then your computer would be part of that global network that is running the blockchain. Because to run the code that adds the new blocks, you need computer processing power. So that's why we have this peer-to-peer network of nodes, which is just a word for computers or the computers that are mining away, which means they're using the computer power to run blockchain transactions and to grow that chain. Now, if you did connect your computer to the blockchain, every now and again, you would get rewarded with an amount of cryptocurrency for letting your computer run the blockchain because you are giving up some of your computer processing power for that. So that's how the network nodes are incentivized to be part of the network in the first place. So it's not volunteer work because technically the nodes, they do get rewarded with payment every so often. So that's how the blockchain is run. It's run by this global network of computers. And if you wanted to, you could join the network yourself. Now, some theories for making a blockchain were actually proposed in the 90s, but it was only in 2008 that we actually got the first blockchain, which was the Bitcoin blockchain. And in 2008, a white paper was published describing how to build this blockchain by an anonymous entity named Satoshi Nakamoto. Actually, still don't know the true identity, but it published it under a pseudonym. And since 2008, tons more blockchains have been created. If you wanted to, you could even create your own blockchain. You could make a clone of Bitcoin or clone Ethereum and then add your own new features. This would take some programming knowledge because, again, the blockchain is written with code. So Bitcoin was the first blockchain, and it was quite revolutionary because this was a new type of technology, this decentralized technology where we have this blockchain where we have this network of nodes and everything that we've talked about already. And with Bitcoin, we also got the invention of the first cryptocurrency. So a lot happened in 2008. And with cryptocurrency, this was a revolutionary way of creating digital money. So this was also very important, and we'll talk more about that later tonight. But this was important because it solved the double spending problem in computer science, which is a method of counterfeiting money. So we'll talk more about that later. Then in 2015, 7 years later, another significant blockchain was created called Ethereum. And in our course, we're actually going to focus on Ethereum for all of the 8 weeks because Ethereum is the most popular blockchain for smart contract development. So we are focusing on Ethereum. There's the most that you can learn about it. There's the largest documentation, most support for it. So you're choosing Ethereum for this course. But if you know how to use one blockchain, then you can pick up another one as well. It's all about your programming experience and your blockchain experience. So Ethereum, why did we choose Ethereum and why is it on this slide? Why is it so significant? Well, Ethereum was actually the first to invent smart contracts. So Ethereum was also very revolutionary because it increased the ability of what a blockchain could do. So Bitcoin, it primarily was created for cryptocurrencies. But Ethereum added this extra feature, the smart contracts, which we've been talking about. Bitcoin has simple scripts, which are like smart contracts, but they're much less powerful. So when Ethereum was released with this smart contract feature, this really expanded what developers could do. Because before, you could write simple scripts, and yes, you had cryptocurrencies, which was very new and revolutionary. But with Ethereum, you could now write smart contracts. So there's a lot more opportunity for programming applications. So what are these smart contracts that I'm mentioning? Let's talk about them next as our next big topic. So we've already talked about them briefly, but let's dive deeper into smart contracts. Everything on a blockchain is created as a smart contract. Every token, NFT, every app, every program that lives on the blockchain is a smart contract. So if you want to put something onto the blockchain, you can write a smart contract. And with a smart contract, you have complete control over what you want to create because you have great flexibility in the types of contracts that you can write. A smart contract is like an application or a program. So it's something that's going to run specifically on the blockchain. So you could build a smart contract for a bank or a school or a store or a crowdfunding campaign, any financial instrument, or a video game. So there's a huge range of types of smart contracts that you can build. So in our course, we will build a range of different contracts across different industries. You have to write a smart contract in code. You cannot write it in English. So just like how you would write a book in English, you have to write a smart contract with a coding language. So in this course, we learn how to use Solidity as our primary coding language because it is the most popular one at this time for writing smart contracts. If you already have experience, that will definitely help you pick up Solidity faster. If you have experience with coding, with any coding language. But if you don't have experience, that's also fine. It depends on the semester, but usually my students are complete beginners to coding. So we will learn the Solidity coding language from scratch, specifically for building smart contracts. So you're going to learn programming topics like variables, functions, events, loops, but through the lens of a smart contract, how we can build those and build smart contracts. And the name smart contract comes from a regular contract itself. If I'm buying a house, back to that example, I'd probably sign a contract with you, which is a legally binding agreement that if I send you the money, you're going to send me the house. A smart contract is the same kind of principle where it's some agreement that something will happen. But it's called a smart contract like a smartphone where it's written with code. So that's why it's called smart. Technically, the definition is a computer program that uses decentralized technology. And again, once you put it onto a blockchain, for most blockchains, you cannot go in and edit the code. You could do a second version of your contract, but you can never go in and erase anything or change anything that you wrote in the smart contract code. And this is to build the user trust, and because of the permanent logging of everything that ever happens on the blockchain. If you want to try building a smart contract, I encourage you to go to remix.ethereum.org. This is the official online editor where you can try coding in Solidity. So you can try building some contracts. Remix looks like when you first visit. It's somewhere that you can write code and you can run it here online. So you'll get 3 examples by default: storage, owner, and ballot. These are examples of smart contracts. So you can see here, this is one smart contract, such as this piece of functionality: give right to vote, to give a voter the right to vote on a ballot. So this is how you can define your application running on the blockchain. You write in code everything the application can do. So if I have a store, I have to write a contract to describe all my products and describe everything that the store can do. Like, can you add new products? Can you remove products? Can you sell products? So we have to define everything about the app with code. Now, I don't expect you to understand any of this right now because this is a smart contract and likely most of you have never coded before. But by the end of our course, you'll be able to understand everything that happens in these smart contracts. So you'll be able to read smart contracts and you'll be able to write your own. So every week we focus on getting hands-on and building out your portfolio of contracts. So here on Remix, you can try typing out some code for contracts like this simple one. You can also compile your contracts, which means you're checking them to see if anything has to be changed. So you can go through, select one of your contracts, and then compile them. If they successfully compile, that means you wrote it correctly, and you can then deploy it, which means publish it onto the blockchain. Now, this is just a simulator for Ethereum, but we'll show you in the course how you can publish to different networks, whether it's a simulator or if it's actually Ethereum. Now, for this course, you don't need any cryptocurrency of your own because we'll show you how to deploy and do interactions on free test networks, which are Ethereum specifically for developers. So you don't have to spend any real cryptocurrency on those networks because they're just clones of Ethereum. Otherwise, if you were testing your projects on Ethereum, you'd lose a lot of money really quickly because you'd have to pay the fees every time you do any kind of transaction. So you can use the simulator to deploy your contracts, which means put them onto the blockchain, and then you can interact with them. You can check out some of their values, and As well, you can run functions like do something, like make a transfer or check someone's balance or check token URI. So, or approve a transaction. So this is just a convenient simulator where you can type some code and then you can try running it as though it were on Ethereum. And then once you're happy with your project, you can put it onto the real Ethereum network, where you'd have to pay the gas fees to put it up. They're not large gas fees if you're doing it once, but if you're doing it over and over every day as a developer, you want to use the free version before you actually are ready to deploy your application. So here on slide 8, I have an example of a contract. This is a very simple contract for an NFT, which we'll talk more about next. So don't worry if you don't understand all this code, because of course, I haven't taught you Solidity just yet. But this is just an example to show you how simple it is to get started building contracts. But if you want to build something more complex, of course, you'll need a lot more code. In this example, we're just creating an NFT that has a name and a symbol. And it's importing some other code from a helper file. But because smart contracts are flexible and you can write the complete contract, you actually have a lot of control about what you want to put in your contract. You know, you could define everything from a bank to a bookstore to some music software to tracking a shipment to tracking some process in your business to just making a to-do list and just tracking it and tracking all the items on the list over the blockchain. So you have a lot of flexibility of what you can write in your contract. If you want to have an NFT with a lot of customization and special features, you would write that into your contract. So this NFT doesn't have any special ability or any special features to it, but you could write them in with code in the contract. So the goal of the course is to teach you each week how to build more and more complex contracts. We start off really simple in week 1, week 2, and then each week we grow our knowledge and we build upon the previous week. So the goal is you'll start with some beginner projects and then you'll grow your portfolio so that by the end you can start solving the software developer interview questions in the blockchain space if you're interested in getting a job in the space, or you can start building your own contracts with a high level of control over them. So if you want to test this, you can just copy the code onto a new remix file like this one here, and then you can compile it, and then you can deploy it and start interacting with it. So just like that, by writing just 11 lines of code, we've written a smart contract. This is a more simple example, but again, contracts can get quite large. It just depends on the project. Our final topic of the night, cryptocurrencies and NFTs. So all about tokens. So let's dive into these two popular topics, very popular in the media. These are the two ways that blockchain is most recognizable these days, is building cryptocurrencies and NFTs. If you want to build your own tokens, again, you write a smart contract. These are just two popular types of contracts, but you can build much more other types as well, which you'll see in the course. So first, let's talk about cryptocurrencies. These were invented back in 2008 with the first cryptocurrency, which was Bitcoin. Cryptocurrencies were quite revolutionary because they were a new form of digital currency that were secured by cryptography, hence the name crypto. And the reason that cryptocurrencies are secured by cryptography is because of the cryptographic nature of the blockchain. So there's a lot of cryptography in how the blockchain itself is checking transactions and tracking cryptocurrency spending and who has done what. So that's more into the side of how the blockchain itself is created, or different ones, how they are all created. Now, the reason that you would want to use a cryptocurrency instead of a digital currency, well, one primary reason is that it's nearly impossible to counterfeit a cryptocurrency, because Bitcoin was the first technology that solved the double spending problem of computer science. This problem refers to the fact that you can double spend a digital dollar by sending a copy of it. A cryptocurrency is nearly impossible to double spend, so we see a lot fewer rates of counterfeiting and fraudulent transactions with cryptocurrencies. It's not impossible, but it is nearly impossible. The reason being that the blockchain validates transactions before they go through. So before you buy your house with your crypto, the transaction is checked on all parties involved. So the blockchain will check if you are the rightful owner of the money that you're trying to spend. Because the blockchain tracks every fraction or unit of cryptocurrency and who is the owner at every given time. So if I spend 1 Ether coin right now, and then 5 minutes later, I try to spend that same coin, the blockchain will prevent me from making that second transaction because I'm trying to spend the same unit twice. I'm trying to do some kind of hack, some kind of counterfeiting through a fraudulent transaction. With cryptography, blockchains track their cryptocurrencies, whereas with a regular dollar like USD, they are not tracked in this same way. So that's why the cryptocurrencies, this technology, was able to solve the double spending problem. Now, since Bitcoin, we have many other cryptocurrencies that have been created. Technically, a cryptocurrency means that it is used to pay gas fees on a blockchain, and it is tied to a blockchain. So Bitcoin is the native cryptocurrency for the Bitcoin blockchain. Ether is the cryptocurrency for Ethereum. ADA is the cryptocurrency for the Cardano blockchain. So technically, to be a pure cryptocurrency, you have to be directly tied to a blockchain. So if you want to build your own cryptocurrency, you would have to build your own blockchain as well. And then your cryptocurrency has to pay the gas fees of your blockchain. We also have cryptocurrency tokens, which are very similar to cryptocurrencies. In fact, usually people just refer to them as the same thing. But there is a technical difference where a cryptocurrency token is a smart contract. And that means it doesn't have to pay the gas fees of the blockchain. It doesn't have to be directly tied to a blockchain. It's just a smart contract that functions in the same way as a cryptocurrency, where it's a digital currency secured by the blockchain. So to build a token, it's much easier than building a pure native cryptocurrency. Because for a token, you just have to write a smart contract to make a cryptocurrency token. But they still function in the same way because they're still cryptocurrencies. Just one of them is directly tied and is the native cryptocurrency of a blockchain. The other one, a cryptocurrency token, it just lives on top of an existing blockchain. So if I want to create a cryptocurrency token, this is the simplest option for creating your own cryptocurrency because you can just build a contract on Ethereum or Cardano or Solana. You don't have to go and build your own blockchain. Another type of token is an NFT. not a cryptocurrency, but it's still a token. A token just means you're representing something on the blockchain. Like a cryptocurrency token, which is also called a fungible token because you can divide it into smaller pieces, smaller units. And as well, each one is uniquely identical in value to the other. Like a dollar bill has the same exact value as another dollar bill. Same thing with a cryptocurrency token. One Bitcoin is exactly the same as another Bitcoin in value. But an NFT is another type of token, so another type of asset that is non-fungible. That's what it stands for, non-fungible token, because it is not a cryptocurrency. In that an NFT, you cannot divide it into smaller units. And also, each one has a different value from the other. So an NFT is used to represent something unique and some individual object, like a house. The ownership rights for a house, those can be represented on the blockchain as an NFT. So that's a great choice for representing ownership or some individual unique asset, like the plot in virtual land. That's another example. Or a video game object or clothing item. Ownership or rights to that can be represented as a non-fungible token. With NFTs, we care about which one do you have. That's what matters. That's what the value is. Which house do you have? What plot of land do you have? Whereas with an FT, which is a fungible token, a cryptocurrency token, with those, we care about how many do you have? How many Ethereum tokens do you have? Because it's all about how many you have versus which ones. I don't care which Bitcoin you have. I care about how many Bitcoins you have. So those are the differences between these two types of tokens. In our course, towards the end, we will learn how to build smart contracts for a cryptocurrency token and a non-fungible token. So we will build both of these and many other contracts in the course. Next, let's talk about the course curriculum. So let's do an overview of the 8 weeks of this course. This course begins on Thursday, so very soon, just 2 days, and there will be a holiday break at the halfway point, but then we'll start up again, so 8 weeks total. I'll drop a link to the course in the chat. You still have a couple days left to sign up. If you buy 2 courses, you will get 10% off immediately. So those of you in web development, I do recommend Web 3 because it's all about the blockchain, but specifically for web development. So blockchain programming, you go to this site, you can see the course plans and the curriculum available. So we have 3 different course plans that you can choose. The first is the self-directed plan. This means you get the whole year's worth of videos that we already have and the code, which is a great opportunity to use as templates for your own projects and start building your portfolio. You get access to the community and instructor support and weekly discussion hour. The other option is live classes, where you get everything we mentioned and you get 8 weeks of live classes. We meet every Thursday at 5 p.m. Pacific, which is 8 p.m. Eastern, for 2 hours on Zoom. And there will be a break at the halfway point for the holidays, and we'll start up again. You also get 6 hours of live Q&A. And for all these plans, you get access to all past, present, and future videos. So this is quite unique because you get lifetime access to the course where you can watch every single semester. Gia is asking, do you recommend this course first before the DApp course? Yes, I do recommend this course first because number 1, it is easier. Number 2, it is shorter. It's only 8 weeks, whereas the DApp one is 10 weeks. And as well, the DApp one is a great next step, or if you already have experience, then the DAP one is totally fine. But yeah, the DAP one is a bit more intensive. So if you don't have any coding experience, then I recommend start with blockchain programming. But it also depends on what you want to learn. This course is more focused on smart contracts, a heavy emphasis on smart contracts. The DAP course has a heavy emphasis on Web3 and dApps. All right, and with this live classes plan, you also get help with 2 personal projects and resume prep and interview prep, and unlimited email and chat Q&A. And again, you get lifetime access, so you can come back anytime. You're not limited to your current semester. You can come back and watch and join anytime after as well. And we have the third option is the project help or tutoring plan, where you get everything we mentioned, and you also get help with building a custom project, including software development, and 10 hours of one-on-one video or phone sessions or software development time. So if you want extra private tutoring or you have a specific project that you want to build, then that third option is a great choice for you. And we do have 3 and 5 month payment plans available. If you don't want to pay all at once, you can pay over time. So let's talk about the curriculum. In week 1, we'll do an overview of the blockchain ecosystem, kind of like we did tonight, but more intensive. And then we'll jump into building smart contracts with Solidity. So we cover the fundamentals at the very start, because usually my students are complete beginners. And then each week you can see here we build more and more complex contracts, where we add more features to our contracts. So we cover all types of programming topics, and we focus on Solidity so that you get comfortable in one language and you can get comfortable programming, and then you can easily transfer your skills to another language. If you already have programming experience, that will definitely help you pick up these concepts faster, so you'll have less homework to do compared to a complete beginner. Then in part 3, we build a cryptocurrency token and an NFT. And we talk about where you can go from here, how you can keep building your portfolio. By the end of the course, you'll be able to read and write smart contracts. You'll be able to interact with Ethereum. You'll be able to have the skills to build your next projects without any help, and to figure out what projects to build next, how to solve interview questions at the software developer interview, and just how to continue learning on your own independently. So you'll have the research skills of where to go from here. So the goal of this course is to give you a streamlined curriculum and to make sure you're learning the correct and most relevant technology in the space. So that way you don't have to learn online on your own and worry about if you're learning the right things, if you're preparing correctly. The whole point of this course is that we made it streamlined for you with the most efficient way possible that you can go from complete beginner to getting ready for the software developer interview at a blockchain company, or building your own project as well. Usually my students, they either want to get a job in the space or they want to build their own project in the space. Those are the 2 most common goals that I see. So our next class begins on Thursday, and the effort is about 8 to 12 hours per week, but it depends on your experience and your goals. We do have optional homework and challenges and projects every week, but if you want to just watch the course, that's also totally fine. And to enroll, you just select the course and it will be added to your cart. And if you choose more than 1, you automatically get a 10% discount. Then you can proceed to check out, and you can choose if you want a payment plan. So you can pay with a payment plan, or you can pay all at once with no interest. And then you can place the order. And right away, you'll get access to the entire video library, so you can get ready for this winter semester, this week, really. It's when it's starting. And so you can watch back, you can get ready and come ready with any questions. If you are in my live classes, the live classes are a great chance because we can do live debugging, live Q&A. Last semester, we had a lot of students sharing their screen. And so I was able to help them right away with any problem they had with the project live. So it's very interactive in the live classes. And if you place your order, you'll also get a link to the live classes if you're in that plan. So you can join over Zoom on Thursday through that link. So it's just that easy. You'll have access to the videos, the code, and the link to join live. Any questions whatsoever, please feel free to ask now. You can also email us. I will drop a link to our team email, alicia@lumiwealth.com. If you have any questions later, you can also send us a direct message on Circle or Discord or make a public post. We're happy to talk over there. If you want to talk over the phone, we also do have times available for making calls. So I will drop another link in the chat as well. So if you want to ask any questions over the phone, you can do that too. If there are no other questions, then we have covered everything we need to cover. So please feel free to ask away now or anytime online. So tonight we talked about why learn the blockchain, what are Bitcoin and Ethereum, and what are smart contracts, cryptocurrencies, and NFTs. So we covered a lot in one night. Remember, you can watch back on Circle or on YouTube. And I hope that you're all excited for this next semester. I know I'm excited to get a new round of students and start a new batch of projects. Thank you so much for joining, everyone. Gia, Patrick, everyone else that was here. And yes, I'll see you online or on Thursday. Thank you, everyone, and feel free to head out.